we have several new folks on the call, not necessarily people who will be attending regularly, but are here for interest in the work our guest speaker is doing. So if maybe everyone who's new to the call today, we could just do a round robin. I'm just going to call you in the order I see you on the screen. And we'll do some introductions, and then I have a couple announcements, and then we'll get to the main event. So Jonas, I see you first.
Hi, so Jonas Almeida, I'm a senior investigator at the CG and data science director for the division as well.
Great, thanks for joining us today. And then Sanjay.
Hi everyone, I'm a data engineer in Cancer and Epidemiology division. I work with Monsi.
Great, thanks for joining. Tal?
Hi, I'm also a data engineer on Monsi's team at the Institute of Cancer Research.
All right, thank you. And are there any other first-time attendees today? Besides you, Jaya, I'll let you introduce yourself in a minute. All right, great. Well, it's great to have everybody aboard. So we got that. So one of the things we talked about doing is having a new meeting time. So the Monday meeting is a little bit problematic because a number of federal holidays occur on Mondays, and especially like November through February, we miss a lot of meetings. And we've got quite a list of OKRs, which are also in the syllabus. So I guess I can share this for a minute. Which are also in our agenda. So if you want to click and see the OKRs, those were presented to the Odyssey community last week. And so we have some work cut out for us this year, but one of the things we want to do is look at tools that might help in this process of getting more survey data harmonized, and specifically harmonized so that we can provide some standards and best practices within the OMOP Common Data Model. And so to that end, I sent out a doodle poll. Of those who responded, Tuesday and Thursday looked pretty close, but Eddie, who's a member of my team who works on the OMOP CDM with our EHA electronic health records, can do Tuesdays at least part of the time and not Thursday. So went ahead and picked Tuesday. So our next meeting will be March 18th instead of March 17th. At 9:30, and we'll see how that works for our attendance. But it'll just mean canceling less meetings so we can get more work done. I put the link to the OKRs if you want to check out what was the slides that were shared out. I also sent you a draft that Friday before they were presented, so everybody should have a copy of those. So without further ado, I'm going to let Jaya introduce himself to everyone, but he's going to be sharing a tool that he's been working on to help with harmonizing data. So Jaya, I'm going to go ahead and give it to you, and I can stop sharing.
Sorry, hello everyone. So yeah, my name is Jaya, and I am in Jonas's research group. I'm a research fellow. My background is in AI, and I've added the link to the slides here. We've been working on this tool called ePharmony, which started off as a library, but now it is a platform where you perform data harmonization, and you're using large language models to help you with that. And let me see if I can, yeah. So there are two main keywords here, and that is large language models and linked data technologies. And if you're not familiar with them, my hope is that I will motivate you to think about them more deeply. And the goal is to do decentralized data harmonization. And traditionally, data from different, for example, in the use case of a consortium which is trying to create a data platform, the data from the different cohorts would aggregate in this one central location, and they tend to perform the chunk of the data harmonization, and then they would store it there. But my intention was that the data harmonization step, and in reality, everything downstream from that is entirely decentralized. And So I'm sure all of you know this, but data harmonization is the process of standardizing disparate data from different sources into a consistent structure and format. So this is in the definition. There has to be a specification of a structure and format in which you want to organize your data. And ePharmony promises to provide three basic functionality that is predominantly done during harmonization. One of them is vocabulary mapping. That is for example, if I'm trying to harmonize a cohort's data against a consortium, um, maybe the cohort likes to refer to age at menarche as age at first menstrual period. And this actually happens in the PLCO study. But the consortium calls it age at menarche. Both the words mean the same thing, but they're syntactically different, but they're semantically the same thing. So in vocabulary mapping, we try to map this. And you'll come to realize that this is actually a very powerful tool because you will end up using it in other cases as well. For example, if you want to standardize your data against standard vocabulary like SNOMED-CT, you would again use this tool. And one of the projects with MONSI, we used this tool for standardizing the pathology data dictionary from the generation study to SNOMED-CT. Data transformation is once you've done the mapping to actually do the conversion from the way that the data is currently in and to the standard format that you want it in. Again, LLMs are involved in the first and the second step. And the third step, there are no LLMs. This is just pure a standard app that I'm using. Quality control. Quality control is once you've done the transformation and you've got the data, you validate it against the specifications that you initially set out and to see that did you check all of the boxes. And if you didn't, it gets flagged here. You could fix it yourself, or you can send back to another round of vocabulary mapping and data transformation. So it's typically a cyclical process, and it's not just one fell swoop. You can do the whole thing. So the motivation is data sharing. That is typical in a data platform that you want to uh, uh, share data in a way that can be analyzed. And then there is decentralized analytics like federated learning, where when you want to build a model across multiple clients, but the clients cannot share the data with you. So the compute goes to the clients, but the data does not come to you. In that case, one of the biggest challenges, like and Elixir in Europe is one great example, that they often deal with this difficulty where the clients do not have data harmonized against each other because each one of them have their own colloquial data dictionary. So my intention was to, in a decentralized way, in a fully automated way, can I do the data harmonization such that I get some level of interoperability to trigger federated learning? The challenges is that currently it is a manual process. There is absolutely no way to track this. People have meetings, impromptu meetings, they have emails. There is no way to track where how the transformation occurred. Sometimes people don't even know whether the data was already harmonized previously. So it's currently a very manual process. And the only way to automate this is through intelligence, that there has to be some domain expertise, some missing context that needs to be filled in, that you cannot simply automate it using a simple program. You need some reasoning steps. The other thing is decentralizations for data privacy as a motivated in decentralized analytics. Uh, so what is a vocabulary? A vocabulary is sometimes called a data model, sometimes it's called a data dictionary, sometimes it's called a semantic model. There are many words for it. A data schema is just a way to specify how to organize and format your data. And there are usually two components to it. The technical metadata is meant to be read by machines, and a descriptive metadata that's meant to be read by humans, like analysts. So the technical metadata would be something like what are the different tables, what are the variables in the different tables, how are they related to each other, and the units, what are the different categories of a categorical variable. So that's the coding scheme. What are the constraints that you cannot have a BMI greater than like 60 or something? So those fall under technical metadata that they're meant to be parsed by machines. And then there is descriptive metadata that describes those variables to you. That's meant to be read by humans, but it is unintelligible to machines. Uh, in harmonization, there's typically a source schema and a target schema. The source schema is the metadata of the data set that needs to be standardized. So in case of a consortium, it would be a cohort data set, and they have their own data dictionary. That's the source schema. And they are trying to reach the target, and the target is the consortium's data dictionary. And I wanted to show you 3 examples where this would be useful, and ePharmony handles all of these 3 use cases. Sometimes, if you're a data platform, there is a consortium's data dictionary, and that is the source schema. Sorry, the cohort's data dictionary, which is the source schema, and the consortium specifies a target schema. If I'm an analyst, and this is the use case that seems to be underexplored according to me, if you're trying to validate some data set against a risk model, then the validation cohort becomes the source schema, and you're trying to reach the target that is specified by the risk model that is being validated. Then there is data standardization, where you have the data can come from a consortium, a cohort, or a risk model, and you're trying to standardize it against a vocabulary that everyone agrees with. So like SNOMED City or NCM at Episaurus. So in that case, that becomes the target schema. The current state of the art in how the tools that are available for data harmonization, one of them is Harmonize and the other one is Usagi, and neither of them use intelligence to help you with the harmonization process. They're both mechanical. Yeah. Harmonize comes from Maelstrom Research, and what they expect is you to provide them. So this tool takes in the different data set from the different cohorts as input, and you are meant to specify how, and there is the data schema. This is their target schema. That this is the consortium schema that you're trying to harmonize against. You are meant to provide these scripts, which tells you how to transform study A into this target schema, study B into target schema, and so on and so forth. But this is the main bottleneck. This is the challenge. So my goal was to automate this step. And then you process the data, and they provide you with this dossier, which gives you some reusability, some way to serialize the information about how harmonization was done. Usagi is only deals with the first of the 3 goals, that is the vocabulary mapping step. What it does is it's mostly like Control F, where you're just doing a plain string search to see if that variable is present in the target, if the target variable that you're looking for is present in the source data set, and if so, how is it named? They do have some degree of semantic search from an old idea called TF-IDF, but with small strings that you typically see in data dictionaries. The data dictionary has a variable and there is a small description. Usually with that short description, a TF-IDF was not very effective. And so I wanted to introduce this idea of embedding model. If you're not familiar with all the large language models that we're hearing about, an embedding model is some kind of a deep learning model that takes as input a string. So in this case, I'm feeding in age at first menstrual period. In reality, what I'm feeding in is the entire row of the data dictionary. And the embedding model maps it to some vector, a numeric vector. This numeric vector has a special property that words that are somewhat semantically similar, they tend to cluster together, and the words that are semantically dissimilar, they tend to be far apart. So in this case, you would expect, and this really does happen, I can show you a demo of it. Anthropomorphic variables tend to cluster together, like BMI, height, weight, hip and waist, they tend to cluster together. Reproductive health variables tend to cluster together, and demographic variables tend to cluster together. So next, what we do is we first, yeah. So what we do is for both the source data set and the target data set, we project them into this space, this numeric space. So right now, this is the source data set. So in the example that I'm about to show you, imagine that the source data set is NHANES and the target data set is OC3's data dictionary. So OC3 is an ovarian cancer consortium. They have specified a bunch of variables that they think are important for predicting the risk of ovarian cancer. And NHANES is this one publicly available data set that you have that measures questionnaire data across the US. So in this case, imagine that in this space, we have embedded all the NHANES questions. And OC3 is about to ask questions to NHANES and say, do you have this variable? Do you have that variable? And so on. So now OC3 comes and asks a question and says, do you have age at minarche? What the tool does is it performs a pairwise comparison between it finds the distance between. So okay, the query itself goes through this embedding, and I project it into the same space where NHANES is. Let's say it lands out here, and now I find the pairwise distance between the query and every single question in NHANES. And then I get this figure. So this is the question from OC3, and these are the different values from NHANES. And it looks like it is closest to this thing called age at first menstrual period. And it is somewhat close to age at last menstrual period, but it is quite far away from age at first full-term pregnancy. So we do a k nearest neighbor search where we define some kind of a boundary and we say that we are only interested in 2 nearest neighbors. So in that case, these 2 qualify and this gets left out. So we find the neighborhood first, and then we do this neighborhood mapping search. So in this example, I'm trying, so imagine if this is age at menarche, then the next question I'm going to ask is who are the nearest neighbors? So let's say you have 2 nearest neighbors, that is age at first full, age at first menstrual period and age at last menstrual period. So let's say that this question maps to 2. I basically feed this into the large language model and I ask it, which out of these 2 does age at menarche map to? And that's where the reasoning comes in. So the large language model is the one that is making this decision. But we ran into a problem, and this is a problem that is very typical in epidemiology. The mappings are not always 1-to-1. Sometimes it is 1-to-many, and sometimes it is many-to-1. And that's the thing I'm motivating with this figure. TNM stage is an example of a many-to-one mapping. So imagine I am querying, this is the OC3 querying NHANES, and it is saying, do you have the T stage? And so the nearest neighbor, let's say it comes to TNM stage, and I'm giving a very minimalistic, simplistic example. The way we solved the many-to-one problem is we did the classic bipartite search graph. What we're doing is we're doing a breadth first search. Not only do we find the nearest neighbors of T stage, we also find the nearest neighbors of TNM stage in the first vocabulary. So we go backwards. So we find T stage, N stage, and M stage. And we feed all of this, so T stage, N stage, and M stage, and the TNM stage from the vocabulary B, all into the large language model. And we ask a simple question, can you semantically map concepts from A to B? This is a simplistic example. In reality, you'll have many more nearest neighbors. So there is a decision to be made. But in this case, it's a straightforward one. It just says that you need all T, N, and M stage to derive the variable T and M stage. Then in the data transform step, we pass in the mapping values. So previously there was no mapping information. The LLM helped us with one. We can bet it. And then we feed this mapping information and we ask another question to the large language model. We say, can you write an R function that transforms the variables in column A into the variables in column B? And it gives us this function that we use to do the actual transformation. And finally, there is a validation step, and I will show you in the demo. But in the validation step, we confirm that once we have done the transformation, it does result in the variable that is expected by OC3. I think this is a good point for demo. Yeah, okay, this is a good point for demo. So this is how I've been, so this thing is still a work in progress. This is the interface that I have in mind. The idea is, so when the user lands here for the first time, they are asked these configuration steps. The first thing they're asked for is a blueprint file, which is a file which is very unique to ePharmony. It tracks all the decisions made by different stakeholders in the harmonization process. You'll see that this will actually help you collaborate with another person, because if you place this in GitHub, for example, the other person who also has access to the GitHub will be able to see the exact same state of harmonization that you're currently on. And as you make a decision and you commit the changes to GitHub, the other person gets those parts harmonized as well. We ask you to provide an LLM endpoint, and we are basically asking for an API endpoint. This API endpoint should host both the embedding model and the chat model. This is the API key that you need to validate again. And there are two models that we're interested in. The embedding model that we just saw, that helps us do this. And then there is the chat model that helps us do this and this. So those are the two models here. And there are two schemas here. Again, there is the source schema that is, in this case, it was the NHANE study, and the target schema, which was the OC3 study. And you have an option to upload the data itself. When you upload the data, you get a few additional tools, and I will show you that. But what my promise is to you is your data never goes to any of the LLM endpoints. You do have an option to host the LLM locally yourself, and I've given some tips on how to do that. If you're hosting the LLMs locally, again, there is no need to do that in this app, because really the only thing I need, you would have noticed, the only thing I ever send to the LLMs is the information that is there in the data dictionary, which is typically made public. Yeah. So you upload the data, and once you've configured it, you can collapse this, and you have these three applications. The first one is the vocabulary mapper, the second one is the data transform, and the third one is quality control. The vocabulary mapper lists out all of the target schema requirements. So so I've created a very simplistic version of OC3. Here it is asking me for age, the age at entry. It's asking me for education, level of education, height in inches, BMI, alcohol in grams per day, and smoking status. And if you want to know more, you can scroll here and see exactly what the data dictionary is asking for. You can make a selection. This part currently doesn't work in my GUI. I haven't linked it up to the LLM yet. But let's say I wanted to do the harmonization of height variable. I basically just check that and I click on Ask LLM, and the LLM basically generates, it does this entire thing step by step. It finds the nearest neighbors in vocabulary B, that is your enhanced data set. Against the enhanced, it finds all of the variables that correspond to height. And then it does the mapping backwards. And this entire set is fed into the LLM, and it determines what is the correct way to map. And I'll show you an example of that here. So here is a different demo that I was doing earlier. Here the question we are asking to is PLCO. So in my example, I was asking questions to NHANES. So now we are asking questions to PLCO. And the question I'm asking is, do you have the variable BMI? And when I press submit, you see that exactly this part goes in here. It says, you remember the first thing it does is the nearest neighbor search. So after the nearest neighbor search, it has determined that the nearest B concepts are these. So within PLCO, there is a variable called BMI underscore current, BMI underscore 20, BMI underscore 50, and all of these are the nearest neighbors. So to see that more visually, let's look at it here. This is the actual, every single question from PLCO is projected in this space. And I'm going to ask the question here. And you see this pink dot is our question. So our question was BMI. Do you have BMI? And so we see, this is a principal component analysis. So it has been projected to about 23%. That's why you don't see them to be an actual nearest neighbor. But in reality, in the 3000 dimensional space, they are the nearest neighbor. So we hover our mouse around and we see a BMI variable here. There's a BMI early adult. So these are the nearest neighbor. And also you'll see that the clustering effect often happens. So for example, all the breastfeeding variables cluster together, all the age at pregnancies cluster together. So semantically similar concepts you'll see, they cluster together. And that's what we're taking advantage of. And then we ask the LLM, can you make the mapping for us? And it says, after having gone through all of this, my recommendation is that you map BMI to BMI current. And it also offers us an explanation for why this makes sense. And it says the other ones don't make sense because this is for at age 20, age 50, and so on and so forth. Temporal variables is another example where there is a many-to-one mapping, this kind of a measurement. So this is the way we do vocabulary mapping. And once the vocabulary mapping is done, we do data transformation. So data transformation, currently, I'm giving you an option for both JavaScript and R, but both of them work natively on inside your browser. The way I'm running R in the browser is through WebAssembly. And there's a project called WebArt that allows me to run this inside the browser. Imagine that you are willing to input the data set to see how the data transformation looks like. So you load that in. You're again asking the LLM to generate this for you. I have pre-generated it for the demo. So I'm going to use JavaScript as an example, but let's say, these are the different mappings that has been done. Okay, so there is some variable called DMDETUC2. This is from NHANES. It is mapping to a concept called education in OC3. BMX HT is a concept in NHANES. Height is a concept in OC3. Again, ALQ 130 is a concept in NHANES, and ALC is the concept is the semantically equivalent concept in OC3. But this is an interesting one. This is a many-to-one mapping where SMQ 020 and 040, these two questions both help you derive the variable smoke. So let's take a look at what happens. So I'm going to show you a demo in JavaScript, but you can see the same thing in R. If you don't feel comfortable uploading your data set here, you can just copy, and it's all saved inside a mapping file. You can just take all of these and you can run it in RStudio, for example, if you're not comfortable. But I'm going to show you the demo in JavaScript. Let's look at this variable. This is the education. This was the categories that was defined by NHANES. So it's less than 9th grade, 9th to 11th. Let's see if we can find something. So there is 3 here. 3 corresponds to high school and GED equivalent. So let's look at that. So it generates this variable. 3 is mapped to 1. So it says did not finish high school. No, sorry, 2. So this is the second column, right? So in the second column, let me just confirm that. The second column, it was 3. That's high school graduate. And that corresponds to 2. And that's high school. So this is the kind of mapping that the LLM has generated the code for. So now you have this reproducible code for doing this transformation. Let's do BMX to height. The interesting thing here is BMX height is in centimeters, but right, yeah, it's in centimeters, but OC3 requires it in inches. So let's click on transform and see what happens. And this is converted into inches. Next, alcohol. This is interesting because this requires domain expertise, right? Like, because you need to know that so the units in ALQ 130 is drinks per day, but the OC3 requires it in grams per day, the grams of alcohol consumed per day. You need to know about this thing, that there is a National Institute of Alcohol Abuse, that thing. Oops. Oh, I don't have it here. Oh, I do. So they define that a standard drink has 14 grams, which is exactly what the LLM also identifies. It says that there is 14 grams of pure alcohol in it, and that's why we're going to multiply it by this number. So we do that transformation, ALQ, and again, it'll all get appended at the end. So we see alcohol has been appended, and it's in grams per day. This is made up numbers, that's why they look a bit crazy. So this is the interesting one. So you have 2 variables that is going to get consolidated into one. This is converting 2 questions. This one, I think it's all here. Yeah. The first question is smoked at least 100 cigarettes in life. So they've been a smoker either in the past, or they are a current smoker, or do you currently smoke? So both of these is used to determine a status of either never smoker, former smoker, or current smoker. So that is 2 variables is consolidated into one. So you press this, and again, it gets consolidated this way. So that's that's the task of data transform. If you're willing to upload your data, you've basically done your harmonization already. Now we again this data comes out to be really good. So I've hard coded an example where there are many problems. So what we do finally after we have done the vocabulary mapping and after we have done the data transformation is we do quality control. Quality control is you have specified all the constraints in your data dictionary, and this checks your data set. And so let's say OC3, right? So OC3 is specified and it says that there are certain rules you need to follow. Let's take a look at some of them. So yeah, so they say that it should be set, so BMI should be set missing if the value is below 14 or above 60. This is one of the rules I deliberately broke. So here also you see height, right? Height has to be it has to be greater than or equal to 48 or less than or equal to 84. So let's click on validate. Again, there is no large language models involved here. This is a standard library that you even have in R, Stata, just about any programming language, because right now your data is in a fully standardized format. And your schema, the metadata is also in a standardized format, which I'll talk about towards the end. So now you can validate it in Quarto if you want, or in this case, we're doing this inside the browser. Again, data is not sent anywhere. You don't need any LLMs to do this. Here you see a bunch of red lines. It is telling you the exact problem that you're violating. So for example, in row 4, the rule that we are violating is that the value must be below 60. It cannot be above 60. That's the exact rule that we are failing. So you remember this one. BMI should be, if it is above 60, it should be set to missing, which is exactly what it's saying. It should be set to null. So let's do that. Let's set this to null. Now we validate it and now it's happy. Now we go into the second row and we see a bunch of checks and so on and so forth. So you could manually fix this. All of this is being traced by the app. So the provenance of all of the changes that you've made is being blamed on some person who is controlling the app. And finally, you download the data. In this case, there is nothing interesting happening, but I wanted to speak a bit about data standardization next. So that's what brings us to Murphy's FAIR paper. So the recommendation from this paper was that data in this human readable format is at the lowest rung of fairness. So it's findability, accessibility, interoperability, and reusability. So the reusability of PDF documents, the data in PDF form is the lowest. Slightly better is using some proprietary softwares like Excel, SAS, and Stata, but it is machine readable as opposed to just human readable. And then at an even higher rung is a non-proprietary formats like CSV, XML, and JSON. But at the highest rung of the ladder is linked data, which not only represents the data in any of these three formats you want, typically XML and JSON, but you also form links between them, and I'll clarify what that means. But before we do that, we need to know the difference between a data model and a serialization format, because in the past, I've realized that people don't get the difference. A data model is just telling you how to structure your data. It's an abstract concept. It is just a bunch of guidelines. I can write it in plain English. But a serialization format is an implementation. It's a technology that enforces that data model. So an example of a data model is tabular data. It just says that your data has to be organized in a spreadsheet like grids. A format that enforces it is CSV. JSON, among many different types of data, it also supports tabular data structures. Another type of a data model is called a data dictionary. A data dictionary tells you the different variables that are there in the table. How are the tables related to each other? What is the human readable description? What is the variable encoding? What is the data type? There is a standard way of specifying data dictionaries too. And that is enforced by something called JSON schema. It gives you a way to specify the metadata about the data. And then there is this third thing called the resource description framework. Resource description framework says that you combine data and metadata and beyond. You link pieces of related data with each other. So if you have a cohort data set, you link it with something like social determinants of health from CDC. You connect that with SEER statistics for incidence rate. all of the related data are linked together, or all the cohort within a consortium are linked together, all of the data. So the same variable age at menarche is linked across all of the cohorts. So if you can find one, you can find all the rest. So the discoverability of the data goes up by a lot through this. And the way to specify that is this abstract notion of resource description framework. And the technology that enforces this is called linked data. That's the technology that we're using in our epiharmony. So why do I insist upon JSON? Well, firstly, it is a web native format. So you'll notice that one of the main recommendations of this paper was to be web native. That immediately checks all of these 4 boxes. And this data format is web native already, because JSON was the format that was used in JavaScript, which was the first native language inside the web. And all the other languages, when they came to the web or started interacting with the web, maybe through like Plumber in R, they still use JSON to send the messages. So whenever you're transferring messages across the web, you're anyways converting it into JSON. So why not just keep it in that format? So all the REST APIs speak the language of JSON. It's interoperable. All languages support it. You don't need to know SQL. You don't even technically need a REST endpoint. If you just point me to where the data is, I will use my programming languages to manipulate the data the way I need it to. Although I don't recommend not doing this. It has a flexible schema. You don't have to enforce anything. If you want to suddenly add a new variable, you're free to do so. You can be organic, just like epidemiology is. The data structure is flexible, and this is also very typical in epidemiology. Like questionnaires are structured where you ask a question, have you ever had children? And if the person says yes, only then the question of what was your age at first full-term pregnancy is even relevant. Otherwise, the question is not relevant. Those questionnaires are not even asked. So those kind of nested structures is naturally supported by JSON. Finally, the storage is supported widely. There are document-based databases like MongoDB. There's inside your browser, there's something called IndexedDB that is also supporting JSON natively. This one. I was listening to a lecture in linguistics, and to me, it was like this aha moment where everything to do with linked data interoperability, they all sort of connected to me. And so this was the simple idea. They in linguistics, they say, how do you communicate in a way that is unambiguous? And they say that it is an interplay between symbols, concepts, and objects. A symbol is the exact words that I'm saying to you. So let's say I'm some of us say cat. Spanish speakers would say gato. So this is just a symbol. I could have assigned this to just about anything. I could just call a mouse as a cat. It's just a name for the object, right? So the name inherently doesn't have any meaning. Each name, we have a shared context, and that context is filled up with a bunch of conceptual names. So when I say the word cat, in your mind, you're conjuring up something. You're conjuring an actual tabby cat that you saw recently, or you're thinking about Tom from Tom and Jerry. So there are different concepts in us. Over time, when you and I converse over time, and we realize that we are actually talking about cartoons, then both of us are actually conjuring up the image of the exact same thing. And that's the Tom from Tom and Jerry. So that we both assign the exact same number. So again, this number doesn't inherently have any meaning. It's just a random number, but both of us agree that this symbol corresponds to that Tom from Tom and Jerry, that the thing that exists in the real world, right? So there is an object. So this is what is in the web programming, they refer to this as a resource. That's where this comes from, resource description framework. It's a language to describe objects in the world. And concept have these unique identifiers called concept IDs that unambiguously refer to something in the real world. The thing is, between you and I, when we had a conversation about cartoons, we consolidated on the idea of what we mean by cat or gato. So we can say different things, but we are both thinking about the same thing. But it's just the two of us who agree. imagine more and more people join in our conversation and they all have a shared context. Now, more and more people conjure up the same image when they think about it. That's called standardization. So SNOMED CT achieves that you have this broad standardization where everyone unambiguously refers to the same thing. And that's the goal of a standard vocabulary, and that's the main thing that's missing in epidemiology, a way to unambiguously label things in site questionnaire or just about any epidemiological data. But what's in a name, right? Like a name itself doesn't have any meaning. So where does meanings come from? Meanings comes from edges between them. To determine that reproductive health variables are related to each other under a same conceptual idea. Also, it comes from links when saying that this column from PLCO study refers to aged menarche, and the same column with a different name in generation study it also refers to this idea of aged menarche. When you do this, when you create these links between concepts, you assign meaning, because now we know that all of these links refer to aged menarche. That increases the findability. It also increases the ability to do data integration. And I have a demo for that, but I'll first finish the slide. So yeah, this is my demo. Standardization, I'm claiming, entails reusability. I think I just have one last slide, so I'll just show the demo. So the idea behind linked data is that you have this data and it coexists with the context of our conversation. And this is the project we did with Monsi, where we have this data and we used epiharmony to standardize the data. So this was a different task than what data platforms typically do. And so this was the data that is generated, and this is a linked data. And the way to visualize this, there are a bunch of tools online. You have it in R. It's a standard, so just about any programming language supports it. But this is my favorite way of looking at it. Yeah, so I'm going to open this. Hold on. Yeah. So this is what JSON LD looks like. And immediately you can tell that this is not meant for humans to read. So, but I'm going to copy this and I'm going to paste it here. And I'm going to visualize this. So now suddenly it makes sense. It's saying that this data, and these are blank notes, which is a variable X, this data has a graphical structure that looks like this. Now I can immediately tell this is row number 1, that corresponds to file ID. This is the value of the variable site. This is the value of screen detected is yes, and so on. This is for the first row. This is the second row, and this is the third. So there are 5 rows in this data set, which is exactly true. There are 5 rows. And if I collapse this, I can see that this is the data dictionary, the JSON schema it conforms to. By the way, this is the reason why I don't allow file uploads here, because I intend to point the data to the schema that generated the whole thing. So which is exactly what we did in this app as well. We forced the user to provide a URL. So they are always web native. So these are the data JSON schema that this data corresponds to. And finally, this is the standardized way of expressing provenance. Here we can see that the process of this data generation was started at this time, and this is the way to format it. It ended at this time. And it was associated with this. So associated basically means that it tells you which app was used. So the name of this app is Medical Report Information Extractor, which is right here. And you have the URL corresponding to that. And this configures that URL. And you also know the large language models. This was the API endpoint that we used. And the model that we used was GPT-4o. So it remembers everything. epiharmony additionally also remembers the edits that you made towards the end. Yeah, so the big magic of having this data in this format, this format is, I already talked about discoverability, right? Like when you find one agent menarche, you'll find the other studies that have also measured agent menarche because you're just following a bunch of links from one depth. But there is also, I said the other benefit is the data integration becomes quite straightforward. And I just jump to an interesting example. So here you have two data sets that have different sets of subjects, but they both measure the same thing. And in this case, they're both measuring the smoking status of the person. So here we can see the data. This is the tabular data. There is participant one, and their value is yes for smoking status, and that corresponds to current smoker. And the second participant says no, so they are a non-smoker. So by the way, this is the concept ID. So in this case, it's a string, it's not a number. It's this thing that we are seeing here. Okay, so then we have the second data set. Again, we have participant 2. So there is participant 1 and 5. There is 2 and 6. So there are different sets of people. But here there is this weird thing. 1 here corresponds to non-smoker, but 0 corresponds to smoker. Again, I've seen this very commonly in epidemiology, where it's not a consistent way of coding the values. So you have the tabular structure within the graph that we display like so. So participant 1 says yes, 5 says no. This variable is called smoking status. Here, participant 2 and 6, different sets of people, but here it's called smoking instead of smoking status. And we know that they both refer to the same thing as the current smoker versus non-smoker, but they just code this differently. And instantly we map this and we get an integrated data set, right? Because this was flipped around. So what I do is I set current smoker to 1 and non-smoker to 0, as opposed to current smoker to 0 and non-smoker to 1. So I flip it around, and now instead of 1 0, we have 0 1. So it automatically integrates this. So if it was something like what Nicole's tool does, where so let's say current smoker, we assign a concept ID of 1. Here we assign a concept ID of 0. Immediately this will break. Those two individuals have disappeared. Let's do the same thing again. Current smoker is 1 and non-smoker is 0. So we flipped this around, right? Now we'll lose everything. So we lose everything, right? The reason is because I haven't mapped to the same standard code. I don't agree to the same standard code, but now I say, okay, I'm going to agree to this code. And the moment I do, I get my data set back. So the point I wanted to emphasize was linked data not only improves the discoverability of the data, but also makes data integration quite straightforward. It's instantaneous and it's supported in all languages. To wrap it up, I wanted to say that EpiHarmony is an open source JavaScript library, and it provides intelligent assistance in common data harmonization tasks. The tool is web native. Everything that is generated is web native. Everything is W3C standard. And there's no need to host anything. It's portable. If you have your own if you have your own web page and you want the users to perform data harmonization there, you don't have to keep redirecting them to the page, the GitHub page where we are hosting it. You can host it in your own web page and let people do harmonization natively where the data is. And it tracks provenance to facilitate collaborative harmonization. The two open challenges that I wanted to emphasize is the need for a comprehensive dictionary. If your data dictionary is not detailed and has foreseen all the edge cases, automation is mostly going to be weak, because you're relying very heavily on the AI to figure the general knowledge of the AI. Which I don't, so that now there is this need for vetting. See, we talked about the shared context. Our conversation has this colloquialism when we start talking about cartoons. That thing is missing. If you want to bring that into the conversation with the LLMs, you need to communicate that through the data dictionary. So if your data dictionary is thorough, in our experience, you can basically fully automate the entire process. You don't have to be physically present in the app. And secondly, and this is highlighting the importance of Nicole's work, to achieve broad interoperability. One of the questions that I frequently get is, can we reuse harmonization efforts of another group? If BCRPP has already done it, then why does OC3 have to start the harmonization from the scratch? Can we just reuse the stuff they already did? And another question I frequently get is, there are different consortiums that have gone through harmonization process. How difficult is it to combine different consortiums? Again, the demo that I was trying to show here was trying to highlight that point. If you want to combine across consortiums, you need to standardize it to some concept ID, some standard you need to agree on. That highlights the importance of a shared vocabulary for epidemiology. So yeah, that's my thought. I can take questions.
Thank you so much, Jaya. That is really comprehensive. It's amazing everything you've built onto this since early days. So yeah, I'll leave it open to questions. And if we run out of time, maybe we can talk Jaya into coming to another meeting. Tom?
Yeah, Jay, that's awesome. Every time I see this, it's like it blows me away, like kind of all over again of how much work you've done. The QC rules that you're when you run the validation, are those being embedded based like what's in the data dictionary? I couldn't quite follow that part.
Yes.
Okay.
So let's take a closer look at a data dictionary. I think this is something that even Monsi has emphasized on. I am using a foreign language here, which might irritate some of you, but I'm insisting that you represent your data dictionary in this format. So in this case, let's see if I can show you an example. So the JSON schema is this way of serializing metadata. So I'm saying that don't use the CSV format that we're used to. Don't have HTML, don't create PDF files, and I'm insisting upon this structure. Now let's look at the exact rule that was failing. Right. Yeah, so here the rule that was failing was for row 4, the BMI was, it had to be above something. Let's look at BMI. So this is BMI 18, there's another BMI. Yeah, here. So here the BMI, we specified this in the JSON schema. We say that this variable BMI, the human readable explanation is this. It's body mass index that missing if under 14 or greater than 60. And we also specified this rule. We say that if the value is a number, if the value is not missing, if the value is a number, it has to range from 14 to 60. Otherwise, it should be null. So we explicitly specified that rule. And that's what I mean by writing a comprehensive data dictionary, like spelling all of this out and making sure you've caught all the edge cases.
So like what we've done in Confluence and the BCRPP with our QC, it's really just kind of merging all that together, like all the other separate like Excel spreadsheets we have with our QC rules.
Yeah.
You're saying just embed that into the JSON data
schema.
dictionary.
And Jonas has shared a link, and I highly recommend it. They don't even assume that you know what a JSON format is. They'll teach you from the scratch, and that's where I learned it too. And you'll realize that expressing data dictionaries probably will take you like an hour of reading. So you'll be pretty conversant quickly.
The other thing, really quick, when the edits that you were doing there, are you actually tracking those edits? So, is there a record that kind of says, okay, this person, I was 100% made the edit there or something? Is there a record that says, you know, we did flag this at one point, just in case anybody ever wanted to go back to sort of see?
Actually, Tom, would you mind repeating? I had a connection issue.
But you know, I see Monsi's also got a hand up. I'll come down to your cubicle and ask you later about it.
Sure.
All right.
Yeah, so thank you. That's very impressive. And of course, until we don't start trying it, it's going to be hard for us, at least for me, to really understand what it does. And for that, I think the first step will be to create these JSON schemas. So is there any, since most of us have data dictionaries in tabular format, is there any tool or something that can help us to convert a data dictionary the way we normally have it into a JSON schema?
I actually have an internal tool that I have not deployed yet. That's how I create all of these, in fact. I can make it public, and particularly reasoning LLM models are very good at generating JSON schemas. But I do recommend that a domain expert go through them and vet it properly.
Yeah, of course. It's just to make it a bit
This
easier.
is just, So
get something
it'll cut down a lot of work.
get started. Yeah.
Yeah. Also-
and then
also
there will be, yeah, sorry.
I was just saying, detailed data dictionary is generally helpful because, an analyst is expecting that. So
Oh, no,
if you
absolutely.
put in the work on the data dictionary, then we are basically helping a lot of downstream effort.
Yeah, and that's one
Agreed.
advantage of going through that is that it forces us to really
Think
have a
about
detailed
the
data
work.
dictionary. So
Yeah,
that's definitely an advantage. And then the second question is related to that. If there might be some fields like type of variable that we might not have in a data dictionary. So are there any tools that can, by looking at the data, can help us assign
yes.
types? So you have many variables, and then we can, of course, check it, but and what would that be?
There is, but in this case, it sometimes helps to have the data exposed to the LLM as well. Because, for
Okay.
example,
Yeah.
date format is, it can infer a bit, but if you feed in the entire data set, it will figure out exactly what the date format is. And that's one of the difficult data types. Date format is usually never specified inside the data dictionary exactly how they've specified it.
I guess one could create a kind of anonymized data set that has a similar,
Yeah, exactly. Yeah.
and then run it to
Yeah.
assign that. And then I know somebody else there. I just want to ask whether you can put in the chat I didn't see it on your presentation, a link to Epi Harmony. Is it possible to the app? Is it possible to use it or not yet?
I would ask you not to use it yet,
Okay,
because
okay, no
I'm
problem.
changing the backend yet. Because if you start using it now and I change the backend, you will not get an update. So that's the reason I haven't been publicly sharing it yet.
Okay.
But that's where the source code is.
Okay, thank you.
Tamara, why don't we fit in one more question?
Thanks, Nicole. I know we only have 2 minutes. This is great. I think this is really impressive. I love it. I was wondering if it's possible to go the other way. If you have a JSON, can you spit back out a human readable data dictionary?
Yeah,
so that
very much.
it's easier to go back and forth, because people will still want to know as well.
So would you consider this what you're looking for? So this is essentially parsing a JSON schema, and I've parsed it in a tabular form. Is this what you were looking for? So you can see the data types.
Yeah, that's pretty good. I think I can read that. I'm human, so
Yeah.
That
for me.
Yeah.
passed
So
the test.
yeah.
Good to know. And I was
Now the
gonna,
rest of us, I'm not sure.
and I was going to chime in. I put some information in here about the concept ID tool. We're hoping to have the MVP finished by the end of the month. So this is a tool that will assign concept IDs within or between data sets, depending on what you upload to it. And it will do that, Tamara. It'll generate a JSON schema with the concept IDs, and you can also get a CSV table out of it. So you can go back and forth between the two. And then you get the added value of having concept IDs assigned.
Awesome, thank you.
So yeah, and I'll have more on that when it's done, but it's certainly playable with now. But anyhow, okay, so yeah, I'm fine with staying on a few more minutes. If those of you who want to can. I see that there's another question. Sanjay?
Yeah, sorry, this might be a bit out of the box. Jay, do you think the size of the data would matter in this case when we use JSON format?
In my experience, the browser can handle easily 2 GB. I've rarely seen something beyond it, but if you do exceed that, like in genomics dataset, yeah, I would probably do the data validation separately. I wouldn't upload the data. I would just work with so in terms of data dictionary, the largest one we did was with Monsi, and we did 6 million concepts simultaneously, and it scaled pretty well. So scaling across data dictionaries is not a problem because we pre-compute the neighborhood. We are not actually doing the calculation on the fly.
Okay.
Yeah, if we're staying on just for another minute, the data transformation, is there any sort of tracking of if the transformation code that is provided,
Yeah,
if you run into an error with it, Like I've had this before working with Claude. It tells me here's the code, and then it's like, no, not really. And I spit back, here's the error I got, and it helps me correct it.
The cool thing is you don't even have to ask the LLM, because this is where the error is generated and I feed it back into the LLM. So the LLM would know that there has been an error. So you don't have to get involved.
But does this depends on me providing the data to it, right?
Oh,
Like if
you're
I can't
worried
provide the
about.
data, like if I'm taking the code and then going to my local machines, like going back and forth between data I have loaded in R and
Yeah,
I'm running it.
then you have to come type in here and say exactly what the error was. Just copy and paste the error.
Well, would that be tracked too, or I guess would like the final transformation code be tracked into that? Yeah. Okay.
Yes. So long as you've updated it, the latest version is what is being tracked. So I'm assuming that you made the change because you have improved upon it.
Okay.
All right. Well, great. Thank you, JS, so much for presenting to us. And thank you for attending and asking some follow-up questions. Jay, would you mind posting your email or how you'd prefer to be contacted if people have questions later on? I want to follow up with you.
Sure. Yeah.
All right. And then we'll go ahead and close the meeting. Again, thank you, everybody. Happy Monday. And we will meet again on March 18th. Bye.